Now we've got a question here. We've got a few little tricks, so we've got to pay a lot of attention to it. So we've got a circular glass window. It's radius 5 meters there, and it requires metal strips for support. So along A to B there, D to C, and F G, we're going to put metal strips. So again, what the question wants you to do, the first part here, the first part we've left out there. We just want this part here to work with. So OF and OG is equal to Y. So we can see OF, OG, both equal to Y there. And FB is equal to X. Find an expression for Y in terms of X. Well, we've got root 5 because that's the radius there. And we've got X, we've got Y. So we can just apply Pythagoras' theorem. So X squared plus Y squared is equal to the root 5 squared. So we get that one. Y squared is equal to 5 minus X squared. And then Y is equal to square root of 5 minus X squared. So there's Y in terms of X. So remember what we always say, we want to get one variable in terms of the other. Well, that's what this part's doing for us. Then part 3, find the lengths of the strips for support and show that that's L. Well, we're going to give it L and show that we can write L as that. So when we look at that, well, that's X, 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 X. So 2X plus 2X plus 2Y. So that gives us 4X, and 2Y would be 2 lots of what we had in part 2. So that's what we got there. Now, the window will have to maximum strength when the length of the supports are maximum. So show that when FB is equal to 2, the window will have a maximum strength. So we've got FB being equal to 2, so when X is equal to 2, basically. So we derive L with respect to X, so we want to find the maximum. So we derive, we get 4. We apply the chain rule on the other part. So apply the chain rule there. 2 lots of 5 minus X squared, all the power of a half. So apply the chain rule there. Multiply by the minus 2x, and then clean it up. The 2 and the half cancels. We get minus 2x on the square root of 5 minus x squared. Now here's where a little bit of difficulty comes in, because we've got to get x is equal to a value. Well, it wants to be 2. So what we want to do, we take the 4 across. Then we'll multiply through by the square root of 5 minus x squared. So we want to really get rid of that square root, so we'll square everything. So 2x becomes 4x squared, 4 becomes 16, and the square root goes, so it's just 5 minus x squared. So then that makes it a little bit more manageable now, because we can cancel the 4 with the 16. Expand that out, we get 20 minus 4x squared. Collect our 4x with the x squared. So 5x squared equals 20, or x squared must equal 4, which means x is equal to 2. So there we go. We want to then test for a maximum. Now, I'm looking at this function, and I'm going to have to do the quotient rule, to get that one. It's going to be a little bit ugly. So I'll just test it in the first derivative. So I've tested 1 on getting a positive value. Should show the value. I haven't done it here, but you can do that. But also I've got to test on the other side of 2. Now, what I've got to be careful about, and we've put that note down here, the radius is root 5, which is about 2.2. So we can't really test 3, because 3 is not a valid value of x. X has to be less than root 5, or at most root 5. So that's why I've tested 2.1 there, and tested 1 that way, that's okay. But tested 2.1, I got a negative. So it was positive, 0, negative, it's a maximum. So that's our one. So we've got to be real bit careful that we're not just testing willy-nilly, and making sure we get that value of 2.1 there. So there's a couple little tricks in that problem that we need to be aware of.